Hi students, in this video we will discuss problems related to inverse trigonometric function. The question is, prove that tan inverse of 6x minus 8x cube divided by 1 minus 12x square minus tan inverse of 4x divided by 1 minus 4x square. We know that tan 3a formula is 3 tan a minus tan cube a divided by 1 minus 3 tan square a, right? And actually we need to prove that which is equal to tan inverse of 2x. Sorry, I forgot to read it. Which is equal to tan inverse of 2x. Our aim is to get tan inverse of 2x. Here in this place, if we want 2x here, because we can take this 6x as 3 into 2x minus this 8x cube can be written as 2x whole cube minus this 12x square can be written as 3 into 2x whole square, because 2x whole square will give us 4x square into 3 will give us 12x square. This minus as it is tan inverse of 2 into 2x minus 1 minus 2x whole square. If you look at this in play, we can compare this formula with tan 3a and we can compare this formula with tan 2a. Already we have discussed problems related to tan 3a and tan 2a, so I am directly getting into this. So 2x can be assumed as tan alpha, from which we can say alpha is equal to tan inverse of 2x. So wherever we find 2x in the question, we need to replace it by tan alpha. So when we replace it, we get tan inverse of 3 tan alpha minus 3 tan alpha whole cube divided by 1 minus 3 tan alpha square minus tan inverse of 2 tan alpha divided by 1 minus tan square alpha. This is equal to tan 3 alpha formula. This is tan 2 alpha formula. So tan inverse of tan 3 alpha is 3 alpha minus, we know that tan inverse of tan 2 alpha is equal to 2 alpha. 3 alpha minus 2 alpha is alpha. We know that alpha is equal to tan inverse of 2x. This is what we need to prove. Here we had 2x, that's why we tried to get 2x in each term. We converted this 3 into 2x whole cube, for 3 into 2x whole square, like this. So based on this term only we have taken and we have proved it. Now I believe you understand this concept. We will move on to the next question. This is a very important question. Sine of tan inverse of 1 minus x square divided by 2x plus cos inverse of 1 minus x square divided by 1 plus x square is equal to 1. We need to prove that this expression value is equal to 1. Actually, if you look at this here, we have 1 minus x square divided by 1 plus x square. We know that here we have to bring cos function here. We know one cos formula, that is cos 2 alpha is equal to 1 minus tan square alpha divided by 1 plus tan square alpha. So we can compare it. Similarly, we have one formula, cot formula here, because cot 2 alpha is equal to 1 minus tan square alpha divided by 1 divided by tan alpha. We know that if we get cot 2 alpha means it can be converted in terms of tan. Actually here we need to get tan. In order to get the tan, if we get this, if you use this formula, we are getting cot 2 alpha. Cot 2 alpha can be converted in terms of pi by 2 minus tan 2 alpha, like that. So if we based on this observation, we can say if we in place of x, if we put tan alpha, it will be easy for us to solve the problem. Hence we say let x is equal to tan alpha. So wherever we find x in the question, we just replaced it by tan alpha. So if we get in this place, we are getting tan inverse of cot 2 alpha plus cos inverse of, we know that this is cos 2 alpha. So we have cos inverse of cos 2 alpha, that can be directly written as 2 alpha. Here we need to get tan function, but instead we got cot function, right? So we are going to rewrite this. We know that tan inverse of x plus cot inverse of x is equal to pi by 2, and by which we can say that tan inverse of x is equal to pi by 2 minus cot inverse of x. If you look at this, tan inverse of x. In place of x we have this cot 2 alpha. So actually this cot, we give angle as an input to this cot function, it produces real number as an output. When the real number goes as an input for tan inverse, it produces an angle. Actually this is the real number. So in this place, this real number can be compared with the formula x, this tan inverse. So this tan function can be written as pi by 2 minus cot inverse of, in place of x we have cot 2 alpha, so we have just substituted cot 2 alpha, right, plus 2 alpha. From here we got 2 alpha. Now we know that cot inverse of cot 2 alpha is 2 alpha, this pi by 2 as it is, minus as it is, this plus 2 alpha as it is. Plus 2 alpha and minus 2 alpha will get cancelled, so we get sin pi by 2, sin pi by 2 value is 1. So we got the right hand side value. So we proved it. I hope you understand this problem. This is a very important problem. Normally when we apply, you know that here we need to get tan function. In order to get the tan function, we will directly use the tan function concept, tan function formula. But here we are getting cot alpha. This cot function is converted into tan function. So please be very careful. I hope you understand these two problems. Thank you students. Thanks for your cooperation.